Hello, everyone. If you've been building AI agents with tools and servers connected everywhere, you've probably seen this. Your model eats 150,000 tokens before it even gets your request. That's because every tool, every schema, every results all get pushed into the context window. So to solve the problem, Anthropic released this blog. They call it all of these MCP clients, they load a bunch of tool definitions. If you see this example, these are two different MCPs and all of these tool definitions are defined here. This is for the Google Drive MCP. And you also have the same for the Salesforce. So these tool descriptions usually occupy a lot of context space, and they increase the response time and even the cost associated with it, even before providing you with a response. And not just that, if you see the intermediate results that come through this tool call could also consume a lot of additional tokens. If you see the Google Drive, if it has to fetch a transcript, which could be quite huge, it has to store that intermediate results that comes as part of this Google Drive MCP call into its context window, and that again cost more money and cost latencies. So this is the major problem. And if you see this diagram, it's a pretty well made diagram here. You have your model and there's an MCP server, and you see the context window. It has the tool definitions and various results of these tool calls. And as we previously discussed, a tool call with Google Drive might result in a huge data that just gets into your context window. In order to solve this problem, they come up with a solution. They call it code execution with MCP. Instead of having all of the tool definitions, they have provided a way to define those tools and even the MCP servers as code, because these models are really good at writing code. So instead of sending every big result back into the model, you process and filter it outside the context window. So if you see, the previous MCP servers could be defined like this in the file system, and the model would write code to learn, provide, and even the results, the intermediate results, are processed within the file system rather than sending it back to the model. So that way, the model doesn't have to consume, or the context window of the model is not exhausted with the tool definitions or even the results that are output from these MCP servers. The way it's done is, here they have provided a TypeScript example. If you see, there is a file within the servers. It's a Google Drive, and they have a get document TypeScript file that provides this code snippet that reads the document from Google Drive. And if this document has to written, or the document that it's been written is like 10,000 rows of file from Google Drive, now that's been processed in the file system, but not within the context window. So in here, you could probably see that the agent discovers tools by exploring the file system. They list the servers, you find available servers, then reading the specific tool files it needs to understand each tool's interface. This lets the agent load only the definition it needs for the current task. So they claim that this approach would slash 150,000 tokens to 2,000 tokens. So it's almost 98.7% of savings in terms of cost, and also the latencies would go down significantly low. Cloudflare has already provided a similar approach. They refer to that as a code mode. It's a great blog. I will share the blog in the description. You could look at this later on. I really love the diagram that they have provided here, in which the approach has been illustrated on how the traditional MCP workflows are and how the code mode approaches. So within the code mode, the agent sends the request to the LLM, and LLM writes the code against the API. So, and the code execution happens in a dynamic, isolated sandbox, because we need security. We need privacy and the code that is written by LLM could not be trusted. So when you create a dynamic isolated sandbox, you have that taken care of. So it executes the code in the sandbox, and even if there are intermediate results that get written, here's a huge file that got as an output from your MCPs, or there's some kind of processing, aggregation, different joins that needs to happen. They all happen in this sandbox. And now only the clean results are sent back to the agent, which again sends that results to the LLM. So your LLM context window doesn't have all of this noise, all of the intermediate results that MCPs provide. So this way you are saving costs, and you also have latencies reduced too. If you see, the benefits that they provide is the progressive disclosure, where you're presenting the tools within the file system, and these models are really great at reading tool definitions from the file system. They do provide this context efficient tool results. So when you're working with large data sets, agent can filter and transform them even before returning the output. And you could also see they provide more powerful and context efficient control flows. So you could define loops or conditions, error handling. This can all be done with existing code patterns, rather than just chaining individual tool calls, which could probably be very brittle as you scale your AI agent with a bunch of tools. And the privacy preserving operations is something really interesting, in which the agent uses the code execution with MCPs, and the intermediate results actually stay within your own isolated sandbox environment. They are not sent back to the model. That way, you're also making sure that the data remains within your own firewall rather than reaching to the model provider. So this is a great model, and they also say there are some state persistent and skills. So every code execution that is done within the file system, it could also be persisted, so that there is a scope for reusability later on if the model really wants to use the existing patterns to extract data or to upload data. All of these are something that agent can store and use that later on. And this is a bit similar to what Claude skills are, which are basically reusable instructions and scripts that Claude came up with, I guess, a few weeks ago. But overall, I feel like this is a promising direction where you could save tokens, reduce latencies with these, by treating MCPs servers as code APIs, rather than filling up all of your context window with tool definitions and the results of these MCP calls. Hopefully this help you to understand the potential that this work has. Stay tuned for more updates. Please follow Agentversity. Thank you.